This is a mini lecture on solving equations. Now, in order for us to solve equations, we're going to have to go back through a few concepts that you have learned once upon a time, and then we're going to go into some examples just to ensure that you have a full understanding. In order to have a clear understanding of how to solve equations, we're going to open with a quick review on how to apply the 4 operations to integers. 4 operations: addition, subtraction, multiplication, and division. We are going to go through an organizational chart that will help us remember all of the different ways that we can work with integers. So with this organizational chart, we're going to look at several different cases. We're going to look at the case when the signs are the same, 2 positive integers or 2 negative integers, and see what happens when we're adding or subtracting, and I'm going to say combining integers. Also, we're going to look at what happens when we are multiplying or dividing integers that have the same sign. Now, what about if they have different signs? We're going to look at that, whether or not we're adding or subtracting, combining, or multiplying or dividing. So the first case, if the signs are the same and we are combining, the operation is going to be add, and we are going to keep the sign. Second case for adding or subtracting, if the signs are different, if we have 1 positive integer and 1 negative integer, the operation is going to be subtraction. And please pay attention to this. The sign is, here we're going to keep the sign of the number with a larger absolute value. You'll hear a lot of times in classes the teacher will say, keep the sign of the bigger number. What do they mean by that? So let's say I had a negative 11 and a positive 3. The whole idea is that 11 itself as a positive number would be greater than 3. But since 11 is negative, we have to look at the absolute value of negative 11. Absolute value, distance from 0. You know, of course, you cannot have a negative distance. So the distance from 0 of negative 11 is positive 11. So when you hear keep the sign of the number with the larger absolute value, you're looking at the absolute value of both numbers. Since this is negative, of course, the absolute value of negative 11 is positive 11, and the absolute value of positive 3. So we're going to keep the sign of the 11. After subtracting, we would get a negative 8. If we are multiplying or dividing integers that have the same sign, the operation, of course, multiply or divide. Here, if you're multiplying or dividing to positives, you're going to get positive. If you're multiplying or dividing to negatives, you're also going to get positive. The last case that we're going to look at is multiplying or dividing integers that are different. Different meaning 1 positive, 1 negative. The operation, of course, still is we're going to multiply or divide, but the sign of the final answer will be negative. Now let's look at some examples so that we can get a full idea of what this chart actually means. So for example A, we have simplify each expression. I have a negative 3 plus 6. Here, combining 2 integers, I have different signs. The rule was if the signs are different, I have a negative 3 and a positive 6, I'm going to subtract and keep the sign of the larger absolute value. I have 3 here and I have 6. 6, of course, is bigger than 3. Therefore, our final answer would be negative 3 plus 6. I'm going to subtract, but I'm going to get a positive 3 since 6 is positive. For B, 15 minus 8, of course, this looks just like what we've seen before, but we're still going to apply the rules to solve it. 15 is positive, 8, I'm going to say is negative. Since the signs are different, we're going to subtract, and we're going to keep the sign of the larger absolute value, which is 15. 15 minus 8, 7. Next, for C, negative 23 minus 2. Since these have the same sign, I am going to add and keep the sign. Negative 23 minus 2, 23 plus 2 is 25. Keep the sign. Negative 25 is our answer. For D, I have negative 7 times 2. Since the signs are different, I have a negative on the 7 and a positive on the 2. The final answer is going to be negative 14. Next, I have negative 25 divided by negative 5. The signs are the same. I'm going to divide, and since the signs are the same, my final answer is going to be a positive 5. For F, positive 4 times positive 9. The signs are the same. The final answer has the same sign, or positive times positive is going to be positive 36. Now, we're going to use the idea of applying operations to integers to solve equations. So when we're solving an equation, the objective is to get the variable by itself. Whatever operation is done to any number that's on the same side of that variable, we're going to undo, and from there we're going to just keep undoing until we get the equation by itself. So here I have t plus 3 equals 6. I want to get t by itself. Here I have a positive 3. I want to undo this positive 3 or add 3. So I'm going to subtract 3. But whatever I do to one side, I must do to the other. 3 minus 3, of course, is 0. So those cancel each other out. I'm left with t equals integer operation. I have a positive 6 and a negative 3. The signs are different. I'm going to subtract, keep the sign of the larger absolute value. 6 minus 3 is just 3. Now you may see why I reviewed integer operation first. Okay, here, 2 times n equals 8. When we're looking at operations again, whatever operation is done to the variable, we undo it using the opposite operation. So if I'm multiplying, the operation that undoes multiplication is division. So if I'm multiplying by 2, in order to get rid of the 2, I'm going to divide by 2. But whatever I do to one side, I must do to the opposite side. 2 divided by 2 is 1 times n. And then I have 8 divided by 2 is 4. Of course, 1 times n is simply n equals 4. For C, I have negative 1/3 n equals 9. So what do? I'm multiplying by 1/3, so I am going to divide by 1/3. Whatever I do to one side, I must do to the other side. And notice I am also grabbing the negative, because in order to get n by itself, it must be a positive n. So negative divided by negative gives me positive 1. This time I'm not going to write it, I'm just going to write n. Now I have 9 divided by negative 1/3, but I'm going to rewrite it this way. So I have 9 divided by negative 1/3, which is simply reminding you of how to work with fractions. I have 9 times the reciprocal of negative 1/3, which is negative 3 divided by 1. So I have 9 times negative 3, which is simply negative 27. I could have also looked at this as negative 1/3 n equals 9. I could have multiplied both sides by the reciprocal automatically to give me negative 3 divided by 1, which, once I do it to one side, I have to do it to the other. Negative 3 divided by 1. And here, these divide off, giving me n, and still here I get n equals negative 27.